Let's look more at properties of vector addition. Is it associative? That is it the case that if we look at the vector x plus y and add to it the vector z, we could get the same result as if we start and add x to the vector that is created by adding y plus z. Is this true or is this always true, sometimes true, or never true? Well, we know it's at least sometimes true based on some of the results we got from the exercises. On the other hand, is it always true? Well, intuitively, I think it probably is, so I want to prove it. I'll start my proof, as usual, by suggesting that x, y, and z are arbitrary vectors. They can be anything. Always true. And I'm going to start with one side of this equation and show that it's equivalent to the other. So I'm going to start with x plus y, add them, and then add the vector z. Now if I go back and use my notation, I know x is a vector, say it's size n, and we would write the components as chi 0, chi 1, and so forth, out to chi n minus 1. And in order to add these vectors, y would also have to be a vector of size n, and we can call its components psi 0, psi 1, and so forth, out to psi n minus 1. After we complete that addition, we can add the vector z, which again has to be of size n because the solution to the sum of x and y is a column vector of size n. We can call the components of z zeta 0, zeta 1, and so forth, out to zeta n minus 1. All I'm doing is using notation, vector notation. And as before, I'm going to write my thinking inside these little brackets for each step. So this is equal to this quantity just by notation. Now, if I add these two vectors using our rule, I'm going to end up with a column vector of size n with components chi 0 plus psi 0, chi 1 plus psi 1, and so forth, chi n minus 1 plus psi n minus 1. So I add the components together. Then what I want to do is add the vector z. This is just vector addition. Now, again, with vector addition, the resulting vector is going to be of size n. Now, to find the components, we'll add the components of the first vector to the components of z. So it becomes the quantity chi 0 plus psi 0 plus zeta 0, and so forth for all of them. Chi n minus 1 plus psi n minus 1 plus zeta n minus 1 will be the last. Again, this is just vector addition. Now we know that each of these components are actually just real numbers. So this is just real number addition. And real number addition is associative. And I can use that fact now to rewrite my vector in the form of the first component. I could write it as chi0 plus the quantity psi 0 plus zeta 0, and so forth. Again, the reasoning is that real number addition we know is associative. Now I think we have it made. All I need to do is back my way out and say, well, what is this? It really looks like it's the sum of two vectors. One of the vectors is our x vector made of the components chi0 and so forth out to chi n minus 1. And the other vector is made up of the components psi 0 plus zeta 0 and so forth out to chi n minus 1 plus zeta n minus 1. This is just vector addition. But what is this? It looks again like the sum of two vectors. This looks like it's the sum of the vector with components psi 0 out to psi n minus 1 with the vector with components zeta 0 out to zeta n minus 1, no matter what these chi's and zetas actually are. Again, that's just vector addition. So, what do I have here? Well, this is just the vector x, and what we have here is the sum of the two vectors y and z. It's just notation. And so it looks like it's always true that the vector x plus y, quantity plus z, is x plus the quantity y plus z.